In this example, a basketball player makes 75% of the free throws he tries. If the player attempts 10 free throws in a game, find the probability that the player will make at most 6 free throws. Okay, so now when we're seeing this at most, we are now thinking we need to use a cumulative distribution function. So let's try and actually write the inequality that goes with this statement. So the probability that he makes at most 6 free throws, and write that as x is less than or equal to 6. So we're looking for the probability that he makes it at most 6 free throws, so x is less than or equal to 6. And well, we know that for this one, that's exactly the form of the binom CDF that our calculator will compute for us. So we can just punch everything into our binom CDF. Okay, well, let's remember now the arguments that we're putting into our binom CDF formula. So it starts with n, which is the total number of trials. In this case, he's making 10 free throws. So that's what we'll use for n. And then the next argument is p, the probability of success. Here we have a 75% probability of success, so p is 0.75. And we're looking for less than or equal to 6, so we'll put 6 as the argument there. Now when we calculate that, our calculator gives us a probability of 0.224. Part B, the player will make at least 8 free throws. So let's try and write the inequality statement that goes with that. So at least 8 means that x is 8 or more, so greater than or equal to 8. Now remember, if it's greater than or equal to, we want to use the complement. In this case, the complement would be that x is less than 8. So we're going to do 1 minus the probability that x is less than 8. And therefore, we want to use the binom CDF Again, we have 10 trials, 0.75 probability of success, and now we're looking at x being less than 8, which means that really we're starting at 7 and going down from there. And that would give me probability of 0.526. In the next example, according to 2017 Washington Post article, approximately 53% of all U.S. households are wireless-only households, no landline. In a random sample of 20 households, what is the probability that fewer than 6 are wireless only? Okay, so now when I see the word fewer than, we're going to look at the probability that x is less than 6. And we know that here, our binom CDF will start with 20 households sampled, so that'll be the number of trials is 20. We had a probability of success of 53%, so we'll use p is 0.53. And in this case, x is less than 6, so actually we'll start with 5 and below. So put 0.53 and 5, right? Because the inequality here is strictly less than 6. So that means that here we're really saying that x is less than or equal to 5. So that's why here we're using a 5 there. And then when we compute that, we get something around 0.0 0.105. In part B, more than 13 are wireless only, so we want the probability that x is greater than 13. Okay, again here we'll do the binom CDF. Oh, sorry, actually, what are we doing first? We want to actually, here, let me correct that. We want to use the complement first, right? Because this is the complement of the probability that x is less than or equal to 13. So we'll do 1 minus the binom CDF. And x is less than or equal to 13, so we'll do 20 trials, 0.53 probability of success, and then 13 successes. Or less than or equal to 13 successes. And this will give us a probability of about 0.0958.